Here we go. Sorry. Testing 1, 2, 3. Good thing I checked on chat. Thank you so much, Swarm Collective. Yeah, I've been recording music more lately and doing some songwriting, and my audio setup has been all over the place because I have a mix of audio gear, like analog gear and digital gear. Things are going great. Thank you for tuning in and checking up and seeing how the stream's going. How are you doing? Hope you're well as well. Also. Okay, so we're going pairwise through the list of the pairs of points on the asteroid. We have P1, PY, PX1, P1, PY1, all the points, the two ends of the line we're going to draw. And then we're going to calculate those offset from the asteroid's position, which is going to be like the center somehow, using some kind of formula, some kind of equation. And then we're going to pass those values off to SDL to draw the line. You say, Swarm Collective is doing well. Opportunity to get back into Haskell for a bit. Awesome. I like to hear it. I hope you're having a good time with it. Of course, we love Haskell on the stream, don't we? I don't love Haskell. Love is a kind of a strong word. Overused and such. I enjoy it. I appreciate it for what it is. I save the love for people. And my kitty. Haskell cat. Okay. All right, so how do we get the offset of this point from our position, as if our position is the origin? I guess we can just add the points to the pos x, pos y. Right? And so if px is an offset from that position, then it's like to the left of our origin point, then it'll be like some negative number. And so if we add it to x, it'll create a point over to the left on the screen, according to our conventions of the geometry of the screen, all that sort of stuff. It's easier to learn while not streaming. Yes, I agree. So far, just wrote a Scotty Y REST API. Right on. Connected to Postgres. Great database. Good choice. So we're building an Asteroids clone. Near the end of in September last year, I wrote a game jam game for the JavaScript 13K competition, which didn't place in the top 10, but did pretty well. It was pretty close. Got some good feedback on it. And I was like kind of curious if Haskell it'd be pretty good for and possible and usable for doing like arcade style games. Of course, we've been building like an interactive game fiction engine, which is slower paced, so like performance isn't much of an issue there. But like an arcade style game. So we decided to start with something simple like Asteroids, as you do. Right? It turns out it is possible, actually. There's a commercial game released on Steam that is written in Haskell. The engine is open source. And I'm kind of meaning once I get to this asteroid clone done to do like a code review on the stream of it, because it probably has some really good ideas and tips for people who want to write games and write more games in Haskell or Haskell-like language. Which is super, super dope and pretty cool. So yeah, the point, so we're going to generate 2 points. Start point. We'll just call it start. And that's going to be a v2, I think. We might have to like finagle the floats to like a cint or something like that when we pass it off to SDL, but let's just make the calculation here pretty straightforward, and we can do that at a later step. So we said this is going to be a v2 where we add together px1 to pos x and py1 to pos y, and end is also going to be a v2 of px2 plus pos x and py2 plus pos y. And oh, that's a do, so we don't need that. Pop, pop, pop. And then this is where we do SDL draw. Is it draw line? I know we've used it somewhere else in the file here. All right, it takes the renderer and then a point, a pair of points. So we'll do start and end. Yeah. Okay, so once an SDL point v2 c int, so we have to construct the point. We did some drawing with lines to get the player ship. SDL.p is the constructor for the point, and the rest is pretty straightforward, I believe. We used SDL.drawLines, did we? Yeah, so we passed a list of these lines, which we can do as well, actually. Now that that makes more sense. We can do one SDL call rather than several. So instead of this 4M pairs, we can translate this into a map. And that should make our code even simpler. It's the points to draw. All right. That's going to be. Oh yeah, and okay, this will, yeah, draw lines will take a list of points. It'll draw lines continuously between all of them. And we just have to, in order to close it off, we just actually have to put the first one back on the end. So this will be perhaps even easier than, even better than we were about to do. Okay. Okay, let's just pretend we're going to do SDL to draw lines here. Renderer points, right? That's not going to work. We have to do something with the other arguments. All right, that's, we expected a vector, a vs.vector, a storable vector. All right, now we want SDL points v2c int, but we actually have a vs.vector v2 float. So we have to, we still have work to do. Okay, so this is the function we need to do to translate our points. right, and then we have the origin point. So we can pattern match this out here. Let's call this like position. I'm going to translate the points based on the position. So that's going to be a v2 float as well. Call it origin here, and then points. Hey. We can pattern match on the list, I guess, in order to get what we need. So I think draw lines doesn't really make a whole lot of sense unless there's 2 points at least in the list. But I don't think SDL will throw an error on us if we pass it less. Just won't do anything useful or interesting or whatever. Yeah, so we should be able to like the empty list and just whatever. We can ignore this. But if we do have it, then we get the origin. Oh, we have this and just a single element. X. We can just translate this into a P. Ooh. We got a follow. Polyvoid, thanks for following. It means a lot. So happy to see you. And yeah, thanks a lot. Great. You made a good decision today. Okay. Blah, blah, blah. So translating the points. Okay, here's what I'm thinking. We pattern match on the list, right? We take and we cons together. So we construct a new list, the list of transformed points. And hopefully that will be enough that we can take the head of our list and cons that on the end as well. Because basically I want to end up with the first point being also the last point so that we draw a closed loop when we pass all these points off to SDL. This is what I would like. All right. So in this case, if we just have one element, a one element list, we can just return that translated point, I guess. Does that make sense? Hopefully this makes sense. So let's pattern match out the origin X and origin Y. And then we go blah, blah, blah. Translate. No, let's just do the calculation in line. That would be easier. V2, origin X. This will be pattern out these parts. V2 PX PY. This PY plus origin Y. Yeah, this wants it to be a list. So the other case we have would be we have a head element and then some more. And then some more P's using the parentheses. And that would be the other case that we have, right? Yeah, so this still wants to be a list. Let's try this another way. Let's try using list comprehension syntax. This doesn't feel quite like what I want to do. We'll worry about closing the loop later. Let's do that. Points. Something where we have a v2 px py in points, right? Okay, so that's an SDL.p and something, probably v2, where we add the components together. Px, py. And now we need to finagle the floats to cints. Which we can do with ceiling, floor, round, truncate. Let's do truncate. See how that feels. Okay, let's not call it P's then. Or points, let's just call it P's. Okay. It type checks. Who knows if it's going to work? So let's add it to our rendering a little bit, our render function here. So we render the player's ship. We render some bullets. Let's render an asteroid. Ooh, I usually put the things I put the renderer last. Thought I put it first, maybe. That's no problem. We have to flip the arguments around. Okay, so we just need an asteroid in there, right? Yeah. Okay, so let's construct a hard-coded asteroid. Let's put it at like, I don't know, 200, 200. And then we'll put some offset points in here. Say v2, -10, -10. I'm not sure if I have the extension enabled to do negative literals, so I'm just going to do the old parentheses, v2, let's say 10 and 10. Let's just make a box. -10, 20. Right, so negative 10 would be the top diagonal corner. 10, 10 would be the opposite corner. Yep. So the bottom left corner would be negative 10, 10. Oh, sorry, Haskell cat's in my lap right now, which is totally fun. It's getting a little too big for this. And then the diagonal corner from that will be a 10 and negative 10. Comme ça. Oh, parentheses. Comme ça. Two V2 split. Oops, I put a comma there. That's not supposed to be there. Oui, vraiment. Okay. Very good. Here we go. Let's see if... Let's compile our program. File watch. And... yeah, don't worry about that. Okay, well, we got to fix the rendering, but there we go. There's something. I mean, that's just our point, the points we selected. Because it's going in a certain order. It's just because the order of the points we have in the list. It's drawing it this way, but it's getting there. It's progress. So let's reorder these. Let's go clockwise around it, say. This is the top diagonal corner, so the next one that should come is plus 10, negative 10. And then the bottom one, 10, 10. And then this one. Yeah, okay. So there's that. And so because we're just defining just the points here, 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 and here around... Well, thanks, Swarm. Yeah, I think we're on, this is stream number 6 or 7, so about 6 or 7 hours into it, with a couple of hours dropped into some not very productive things. Semi-productive things, but I'm going back on an idea we've been working on for a stream or two, so yeah, about 5 hours or so. Not too bad. So that's, but we're only doing the corner points. What I would like to do when we're with the rendering, so we'd only specify the corner points of the asteroid, and the render function will create the closed loop for us. So we just need a function that takes a list like this, right, and adds the head element of this list, if there is one, to the end of the list. All right, so if I bring up my REPL, or maybe I could just do this in a comment. Right, I should have, if I get the empty list, then that should just return the empty list, of course. If I have like a list with one element, we should get, it technically has a head, so we should have a list of 2 elements. And then if I have more than one, like 2, I should get 1, 2, and 1, like this. Or, yeah, skip rendering it altogether if there's fewer than enough points to draw. something sensible as well. That would be useful. We could also like increase the requirements on the asteroid type to say like, in order to construct a valid asteroid, just construct a valid one. Don't even bother constructing these nonsense asteroids that have fewer than 3 points. Right, because their second case here only that's only the same as drawing a line. Which, like, is something to draw, sure, but not super useful. At least for when it comes to rendering asteroids. So we could be more specific here. We could say, like, instead of not even non-empty, non-empty wouldn't be enough, because it would be at least one. We'd have some other type that could say, like, I don't know, at least 3. So that's one way you can go about it. You can get really specific with this sort of stuff, and I generally choose that approach when doing functional programming. But sometimes you can get, like, you can really code yourself into a corner and getting overly restrictive. And it becomes just a pain to deal with. So I like that idea. Since rendering the asteroid, we can know the size of points, and we can just skip this if it's nonsensical. We can just short circuit. So if we could put a guard on this, or we could pattern match. A guard might be less typing, maybe, but right, and then we'd have asteroid. And something with one element doesn't make sense. Also pure. Oh, kind of like automatically clean it up even, well. Yeah, just drop enough points from it to bring it under that condition. Yeah, maybe. That's one way you could do it. It would be very unintuitive reading the code, I think. Well, not intuitive, but like not obvious unless you commented that really well. All right, so that's becoming a lot of cases. So we could do it with a guard. If it's less than 3, then just pure unit. Otherwise, render something, please. Let's see if we don't force this is kind of the pattern that happens when you don't force preconditions on your callers by using more specific types. Your code will have more of these kind of edge cases that like don't make sense and you don't really need to you don't want to handle, but you have to because of the type system. So it's just a trade-off there. You have to sometimes decide whether it's worth doing one or the other. All right, so if we have this guard length 3 points and we just return unit, we just don't do anything. Even though technically this is our game, and when we're constructing asteroids, we're not going to have this case in our code. We still have to have it there because we haven't used a more specific type. Lists can be empty. they can be less than 3 elements. We could also be more, we don't have to, actually, there's another, that's a good point. Maybe we just say like an asteroid has 8 points, 6 points. Whatever points they are, they can be any values you want in them, whatever offsets you want, but you give me 6. And that's that. And so we can fix that size with a tuple. 1, 2, 3, 4, 5, 6. That's kind of a lot to take in there. So let's create a type alias for that. Which you almost never want. Asteroid points. Let's derive equal and show for that. And there we go. Okay, and now we're very, very super specific. Let's just say they have 6 points, that's it. Then we don't have to worry about, is it less than 3 points? Is it more than 3 points? We don't have to find a type that says at least 3. Okay, that messes up this code, but we're gonna not use that for now. But then we can remove this guard. Which is just noisy, dumb code we don't want. Okay. And now we're no longer doing really like a map or from list, or we have to translate that tuple into a list first. Asteroid. Let's call it asteroid points list. To a list of v2 float. Let's just call it asteroid points. And if we put that here, that should still work. And just leave us with this fancy little hole. Yeah. And then we got to pattern match out all 6 points. P5, P6, and that just becomes a list. What don't you like about this? Oh, yep, sorry, merp, tuple. And we can probably get rid of that tuple actually and just make them arguments. We're just going to pattern match them out this way, and then we can get rid of a couple extra bit of noisy syntax around it. that. I'll take a slightly noisy definition over a noisy term. Why not? Oh, that's right, because new type. Sorry. Brr, that's why it needs to be a thing. Oh well. Oh well. We'll just have to deal with it. It's not that bad. If we made it a data constructor, we could probably do it instead of a new type constructor, but this is fine. Okay, that's cool. So translate asteroid points whenever we get render asteroid. That's not the type error anymore. It's down here. Yeah, so we just need to turn this into our new type wrapper. Make that a tuple, not a list. And then we actually have to pass in the right number of v2s. So we have to put in one more. And so we have to construct it correctly. Now, we can still put junk in here, but we have to give the right number of points. Am I missing one? 1, 2, 3, 4, 5. Yes, I am. V2. Oh, no. Let's do -10, 0. Not too many parentheses. In the wrong places. No, astro points is right. What was the problem with this? Expected type, asteroid points, actual type, asteroid points. Comma, something. Oh, Let me pull this out. Confusing myself. And this is why you don't want to be learning a programming language on stream, by the way. This is a good time to put P1 at the end of the list. No, I still want the renderer to take care of that, the rendering function to take care of that. That's more of an implementation detail of how the SDL render lines function works. It doesn't close the loop of points for you. And it's nothing to do with how we define the points that we're trying to define on the asteroid. We're converting the tuple to a list in the rendering function. Yeah, that would probably be a good point to put it in. Once I get this fixed, we will look at that. Is it because... there we go, an errant parenthesis. Oh boy, I messed this one up pretty good for some reason. Okay. we have 1, 2, 3, 4, 5, 6 points. That's right. Oh, there we go. That's wrong. One, 2, 3, 4, 5, 6. Now what's the problem? Ah, here. There we go. Finally. Okay. Oof, man, formatting matters. You know what I'm saying? Yeah, so where we're converting this tuple to the list. Yeah, that would probably be a good place to do it. So I think this is all compiling, so let's just check it out, make sure this is all well and good. It looked like it was kind of working there, but it might be a false situation. Just because of the way I defined the points. I just want to make sure I'm not tricking myself. Did I already? Hopefully I didn't already do it. Let's make this ridiculous. Something like that. Finish compiling and linking. There we go. Yeah. Interesting. Oh yeah, because I did put that point back in there. So yeah, I think I am tricking myself here. Let's make this -10 and this one say like 5. There we go. So if the loop closing part worked, there would be another line here connecting back to this point in the top left of our asteroid here. So, yeah, let's go and do that. Render, I think that was in render asteroid. Yeah, here. So we just put P1 back on. And now it should be closed every time. There we go. Yeah. Asteroids. Okay, so that's nice and dandy and handy. Let's make this slightly less ridiculous. Yeah, something asteroid-like, tiny asteroid. Let's move a couple of these points around a little more. Bum, bum, bum. 21, 11. Yeah, let's say that's our little asteroid. Okay, cool. Do we want to get rid of the generate asteroid code, or should we hold on to it commented out in case we want to bring that back? We can update this function to make it type check again. Make it kind of work. Yeah, why don't we try that? See if we can hold on to it even though we're not really using it, and then maybe we can decide if we're going to get rid of it and another commit. So it's going to be a list of floats, not a list of v2 float anymore, but asteroid points. So this suffers actually the same, well, not the same, a kind of problem too, where yeah, let's just get rid of the generate asteroid function for now. So our change will be remove the generate asteroid function, or our change will be add a static asteroid. Yeah. Okay. Cool. And now that we have that, we can move it around. So we're going to have, in the game state, just like we have for bullets and such. What the hell is going on with my Emacs here? All the bullets, we're going to need the asteroids in the game state, of course. All the asteroids that we're updating. So let's go ahead and add the asteroids to the game state, and then we'll add our single asteroid to that initial game state and update it from there. We'll get it moving and wrapping around the screen and all that stuff. They also do rotate and stuff. We can add that as well. Let's get it moving first. No, it's really pulled over to the left, to the right, isn't it? I don't like how far over to the right that is, but yeah, yeah, it's not gonna fight it too much. Okay, that's such an annoying change. Look at me making white space formatting changes. Any hoozle. It's my own code. It's our code. It's fine. It's not that big a deal. Any hoozle. What are we doing? Moving asteroids. Okay, so game state. Where is our game state? There we go. Asteroids. It's going to be, what did we use for bullets? A deck? Well, let's use a deck for that as well. Okay, so we have to update our initial game state. Asteroids. And now we're not going to start with empty. We're going to do a single one. So, let me go grab that. I'll grab those points and this. And we'll put that here. And then I gotta check if I have deck in scope here. It's D, okay. So I think it has probably, if it's following the other collections libraries, a singleton constructor with our asteroid in it. It doesn't. I didn't mean vs.singleton, no. I've looked up the documentation on that again. Cons, reverse, knock, shift left, shift right, blah blah, take, drop, blah blah. Init. No, no, not that, no, no. I guess we can do from list, because it implements that. Okay. So how does that work? Do I do just like this? Is what it's saying? Initialize it like that? Oh, that's an error. What can I put there? Haskell says the only valid whole fit is empty. Oh, goody. That's not very useful. What does it mean the typical to-list and from-list conversions are provided by means of the foldable and is-list instances? Let's check is-list. Maybe that's got it. From lists. Okay, so a very generic from list function. Do I have to import that? Do you re-export it? You don't? Okay, so I have to import isList. That's a GHC specific thing, isn't it? Is it? Extensions. Okay, or foldable, it said. Okay. I don't want to list. No. Okay. GHT.extensions it is, I guess. Let's try that. GHC.ext qualified. Mm-hmm. That's a weird API deck, but there you go. Considering the GHCX package tells you not to depend, well, it tells other bases not to depend on it, but still. That's kind of weird. I might suggest a change and maybe implement that sometime. Okay, so jump to our next type error. Render asteroid. Now we have to get the asteroid out of the game state. So we're going to need render asteroids function, which is going to get the game state asteroids and the game state renderer. And now it's not going to render just one. It's going to render many. That's going to be pretty simple to implement. Render asteroids. I'm just going to take a deck of asteroids on SDL.renderer and render them all. This one, just do 4M. I might be able to add or reduce, maybe add or reduce. I'm not sure. Anyways, 4M asteroids. And then here is where we're gonna have to do, because the argument order, we're gonna have to do it like this. Render asteroid. A renderer. Okay, that compiles, and if we run this, it should work. Yeah, there we go. Cool. So let's create a commit. Add asteroids to game state. Now we can do an update function. We can update an individual asteroid. This will take an asteroid and some time delta, probably. We could take the game state, the whole game state. Yeah, let's take the game state. And return a new asteroid. Something like that. And then update asteroids. Take our deck of asteroid, a game state, and return a new game state. No. Well, with bullet physics, we took deck of bullets and return a new deck of bullets. So yeah, let's return a new deck of asteroid. That seemed to work. So we have asteroids and state. To get a new deck, we can map some integration function over all the asteroids, right? We have that. Although, I guess we should flip the arguments. So let's compose as well. And then actually I can flip that around as well. Oh yeah, we don't have map on deck. What do we got? Hmm. We have a way to map into the elements of it, I guess, inside the deck. There we go. Now, assuming we still have to implement update asteroid. We're going to update the individual state of a given asteroid using that function. Let's wire it up to the game state first. Actually, let's just make upstate asteroid do nothing but return the asteroid. Even though that's kind of a silly thing to do for now. Just so we can wire it up. Into our main physics update. Okay, so there's our update loop. Game state, game state. So next state. Game state asteroids. We're gonna update asteroids. We gotta pass the current game state in. State and game state asteroids. I mean, I guess update asteroids, if it's getting the game state, it'll have a reference to the asteroid in the last state already. So we might be able to shorten up that code. I don't know. For some reason, it reads weird to me when I look at the type and I say update asteroids, but it's game state to game state. And you're like, okay, like it could change anything about the game state. So, I don't know. It's probably fine. But if we don't like it, we can always change it later. Factoring is super easy in Haskell. Okay, so that's good. That compiles. It's happy. The only real reason why we're bringing in game state is to get at the ticks and stuff. So when we do like our motion with the asteroid, we can compute its next state from those variables. Right, which we're going to have to leave this undefined for a moment, actually, because we don't have enough information to do that motion, right? We need a position. We have a position, but we need a velocity vector. Right, just like we did for bullets. So let's change that. Asteroid velocity. Velocity. Thank you. Fingers. Work. There we are. A V2 afloats. Okay, we don't need it to render an asteroid. And construct an asteroid. We have to give it a velocity to start with. And let's put in something silly and somewhat useful. A starting velocity of 1.2 on the x and 1.2 on the y. Now this is something to note, possibly for maybe next stream. This is like the third time we've implemented motion for different game objects. So we might want to refactor some of that out a little bit, some of those common elements, so we can have like a single way of updating the velocity and the motion of objects in the scene. But we're not miring ourselves in those details right now. We'll just update it like this for now. So asteroid points velocity. Now we have enough information to do this this movement. So looking at bullet, update the physics, right? This is the exact formula, and it's going to be the same thing for the asteroid. Almost the exact same equation, right? Which is kind of like the hint of why we're going to be doing. Swarm, what sounds like an interesting package to put up on Hacketch? A basic, like a vector physics, arcade physics library, maybe? We just have to fill in our asteroid variables here. So our asteroid position plus our asteroid velocity. Yeah, exactly. Maybe there is one, and I just haven't looked. So we'll pattern match out. So we'll grab a reference to that. Oh, sorry, not bullet position, asteroid position. Mid. And then if we run this, now it's slowly moving. Pew, 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 pew. And the goal of the game will be to, you know, shoot these things with bullets. Meow, 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 meow. So we don't use... Actually, I thought for some reason that we would use the game ticks for this motion. Feels weird that we're not. But it is a constant motion. It's probably subtly wrong. But we aren't using any of the values from game state, so we might as well take it off for now. We can get rid of that. We don't need that. That. And then we don't have to pass this in. Cool. So let's just review the change now. That's good. Add velocity, update the asteroid. Render it. That's just a fix for the type because we have the extra field. Add a statically defined velocity for now. So I think I'm not going to get rid of the pseudo-random generator that we built on the prior streams just yet. Because even though we're not going to generate perhaps like random-ish polygons, we're still going to need to, like when we initialize an asteroid, get a somewhat random starting velocity vector for it and position. At least for those initial asteroids when we're like starting up the game. And when we spawn one in periodically, so we'll probably also want some kind of timer event that happens every so often to spawn in new asteroids, or some way of doing that. Maybe like when one gets destroyed, we spawn in another one or something like that. I don't know how the game rules are going to work quite there with that quite yet, but those are things we can consider. So let's commit that. Add asteroid movement. Okay, so now they're moving. We can add, they also rotate a little bit when they move, which is kind of cool. I mean, we could leave it static, but it'd be also nice to do it rotation, some rotation. We have this rotate origin function that we use for the ship. And we could use, looks like we could probably use this for our asteroids as well. All right, so this rotates 1 point around an origin. And so we need a float for our rotation in radians, and looks like an origin point to rotate around, and the SDL2 point that we want to rotate. And so if we map all of that rotation to all of the points in our asteroid definition, then we should be able to rotate the asteroid as well. So let's see if we can implement that quickly before we run out of time tonight. So we'll go to our asteroid definition, and we'll add asteroid rotation. Float. All right, that's going to complain here. And I think we got one more. Yeah. So let's add this mild rotation of like 19. Oh, sorry, wrong place. There. Stream brain is slowly starting to kick in. Also, my Emacs is acting really strange. I must have corded something odd that I didn't mean to. Okay, there we go. Oh, screen lock. That's what it is. What did I do? How did I turn that off? Turn that off. Much better. Okay. And right. So now that we have the rotation, when we go to update the asteroid, we can update the position of all the points based on current rotation. So rotate it by a certain amount. Should we do it to... Let's see. Yep. Right. So it's only going to... we can rotate the points using this function, like we do rotate around origin. We map all of those points. But in order for the rotation to keep rotating, we have to increment the rotation every frame. So let's also add a rotation speed to the asteroid. It's not only a current rotation, but asteroid rotation speed. We can make that a float as well. Okay, so when we update the asteroid, we can increase the rotation by the rotation speed. And then we have to change the asteroid points. And we don't have a map function on, well, we could implement, if it wasn't, it is a new type. Yeah, we could implement functor for this so that we can fmap over those asteroid points our translation function, rotate origin with the asteroid position and the asteroid rotate, the current rotation. Which we need to turn into cint. And then we have to pass in the asteroid points. Yeah. So we can make that a function so that that just doesn't go off the screen too much. Let's call it rotate points. Okay, so then we just need to implement some kind of the functor interface for this new type. Right, and so in order to implement this class, we have to implement fmap. A, B, C, D, E, F, G. F, A, F, B, F, C, F, E, F, E. Oops, that doesn't work. I'll just put a tick on it. Fine. Not technically a functor because it doesn't take an argument. It's not a hider kind of type. All right, well, we pretty much have the function. Let's not write it as a functor instance. Let's just call it map asteroid points. And so call map asteroid points a function from v2 float to v2 float. And our asteroid points. And get back a new asteroid points. A, B, C, D, E, F prime, G. That's A, B, C, D, E, F, G. Oops. Too many. Hee hee. Okay, there we go. So then we don't have fmap or rotate points. That's fine. Just replace that with our very explicit asteroid points. And we probably have an STL C int thing again. Right. Okay. So did that truncate SDL points? Okay, this is because well, let's fix this here too. This is because I think we're maybe just getting the wrong types in there. Rotate origin. Yeah, so we did that one, but yeah, okay. And the point we get in, so we have to convert our input points that we're mapping over to SDL point in order to use this. Okay. So that comes in front of this. No. We can compose it with this one. There we go. Okay, 2 point, let's call it. SDL.point v2c int. SDL.p, and we're going to do truncate over the v2. Oh, and coded myself into a bit of a corner here. Okay, so asteroid points. So now we need to map those rotated points out of SDL points back to our floats. And I messed up this function. So now this is screaming to be a functor. It's not composing very well. Right, it wants to be an A here, so we can make these all A's so that we could have A, right, and it'll be astro points v2 floats, but then we can convert SDL points and back again, but still have asteroid points as kind of like unchanged. Right, it's just the units inside here, the types inside here that we want to mess around with by providing a function. Right, because then we can map 2 into the rotation to do it in SDL points, and we can map back out into floats again. Whereas this function, map asteroid points here, v2 float to v2 float, means we can't go from we can't use the rotate origin function because these are hard-coded to floats, and the origin function returns SDL points. So if I change these all to A, we have to change the type now of asteroid. So they're not asteroid points, we have to specify what they are. V2 float. All right, we won't need this quite so much. This can become fmap again. And then we can get rid of this and turn it back into just fmap. Now this hole should be asteroid points, SDL point v2 c int back to our SDL v2 float. So we write from point and convert it back. This means we're going to be losing information converting to and from these floats when we do all this truncation. Hopefully it won't matter too much. Yeah, super Haskell magic, or really boring Haskell. Functors are everywhere. But they're very useful. We love them. So I think the SDL.p is, we could just peel that off. And then, oh yeah, and then we have to fmap that into float. Okay, now what is our problem here? Probably my type of rotate points is not quite right. Or at least not what I think it is, so let's write it out. Our F0 container is just asteroid points. So let's just tell Haskell that. Okay. Oh, yeah. We want to... No, not quite. Compose the fmap with that. Okay. Yeah, so then v2 float. I turned screen lock back on. Let's see. Couldn't match. Load. Oh, right, because we had added the rotation stuff. Let's initialize it with an initial rotation speed of 0.8. Okay, well, we're back to compiling again. Let's see if it actually works. A little too well, it seems. Eee, look at it go. I don't know if you can see that on stream just because it's like wiggling around so fast. But our calculation on the rotation's just slightly off. Just a little bit. So it's definitely rotating around a point, but all of the points, and it looks like the origin is like maybe not right, or not what we expected anyway. Okay, let's just take out the rotation updating and just draw it statically at a rotation. Oh, I might have started that before we finished building. No, it's definitely, did I do the right thing? It's not quite doing what I was expecting there. I expected when I took out the rotation that it would stop doing this. Rotate asteroid points. Rotate the origin around the asteroid position of the asteroid rotation amount. All of the points. Okay, it is visible, but you have to look really close, yeah. I mean, I have to look pretty close, too. It's pretty tweaky. Okay. Hmm. So, yeah. What's going on here? The origin of... So the rotation, the value we're passing as rotation should not be updating or changing. And the input point is one of those offset points. I wonder if it's because the points in the asteroids description are offset points. Where the player ship points when we're rotating them are absolute. They're calculated. Be the position plus an offset. That's probably what's happening there. So we can fix that. Before we call rotate points, the asteroid points, we should calculate the absolute values, like I'm calling it the absolute value, but like it's the position plus the offset points, and rotate those around the position. I think that's probably what the issue is there. Abs points, I'll call it. It's going to be asteroid points, V2 float. We'll need the position. And we'll give back an asteroid points of V2 float. That should fix it. Yeah. Origin X, origin Y. And no. V2 float to V2 float. That's going to be asteroid position. And this will be our base. And we'll take, oh, thanks for the follow, Dundiff. Very much appreciate that. I hope you're enjoying yourself and having a great day. So we do PXPY, hopefully that's not shadowing anything. What's going on, Dundiff? Interested in game dev, Haskell, both? So then we're going to do a V2 with the origin X plus PX and origin Y plus PY. So transform those first. Well, it's still rotating around for some reason. Why is it rotating around in a weird way that I'm not expecting? Am I using the wrong variable somewhere? Rotation, position. Sweet. That's all right. So do you use Haskell? Something wrong with our formula with here. We map over the asteroid position with the origin position to make sure those offset points and the asteroid points become not relative to the origin, but like the actual like position on screen, which is what I think I wrote rotate points, rotate origin. So we get the sin and cosine of the rotation. So we get the x and the y change of the rotation around the circle. That makes sense. Oh, perfect. Well, that's awesome. Welcome. Welcome to the stream. Functional programming is amazing and fun and useful. But we are running out of time on this stream, and hopefully we can get this fixed before I gotta go. Yeah, so we get the ascendant and the cosine from our radians, which gives us a point around the edge of the circle that we want. We get the SDL2 point on line 413 here by taking the input point, which is a V2, subtracted from the origin, so offset from the origin. And then we take x all right, so then we translate that point x on around this part of the circle and the y. We get the y value from that. Yeah, so that formula, the input points here should be should be what ship points does calculate collects all the points together as position plus these as absolute like screen positions, not offsets from some position. And then we call vs.map to map each of those points around position with rotation amount. Yeah. Huh. Huh. And if we look at our asteroid, ooh, maybe it's a rendering problem. How do we do those rotated points with render ship? Oh, we do the rotation when we render. Okay, and so this might be doing something weird because when we put those points back in to the state, that's probably it. When we update the asteroids, we're changing the asteroid points on each asteroid in the game state. Right? We return a new asteroid where the asteroid points are this. Right. This makes sense now. So this is the problem with this formula here, this equation. We're changing the asteroid points to the rendered screen space points, not keeping their offsets. Right? And the way the ship logic rendering logic works is it figures out the rotation of the ship's points at render time, not in the update. So all we have to do, we just kind of have the code in the wrong place. In order to fix this, we just have to put all of this rotation logic in our render asteroid logic to render based on the current rotation. And then in the update part, we just have to update the rotation. And then we're done. That's the whole problem. Stream brain. Okay. So all of this code I think is still pretty useful. And this part, we don't have to change the asteroid points. Okay, so when we go to render an asteroid, so we're going to paste back in some of what we had here. Abs points has almost, it's almost translate points. Yeah. Okay, so let's turn this into a record wildcard. Fix all that. Change the name of that to asteroid points to list. So we translate the points, then we rotate the points around the origin based on the current rotation. which we're going to have to change the type of some things here. Probably rotate points. And that's going to take the asteroid position again. It's going to be a list v2 float. And we have to return a list of SDL.point v2 cint. Rotated. Yeah. Okay, turn this back to map. Oh, I got an extra wear in there. Not bad. Down. Just fix all the type errors and it'll be good to go, right? Origin P. Or maybe we can just call it origin without interfering with anything. Almost there. Oh, we want translate points. Oh, we're going to take, okay. So translate points gives us the SDL point already. We don't need a 2-point. Let's see, cint with float. Sorry, cint. Don't actually need those. Okay. Now, there we go. Rotating super fast and moving. We can probably slow down that rotation quite a lot. The rotation speed. Yeah, we were changing the rotation speed, right? Update asteroid? Yeah. We probably don't want it to go quite so fast. There we go. We'll probably just lower the rotation speed a little bit. That'll be good to go. Make it like 0.2. That's a little better. Woohoo! Rotating, moving asteroids. Perfect. Let's get that commit up. I accidentally closed my editor because so cool. Super cool. And now, yeah, there we go. We're getting there. Not too shabby. Thanks, Swarm Collective. Not too shabby. Right, so we learned a little bit about using types to like push constraints up to callers, or you know, letting them kind of propagate downwards to our code and having to handle them. In this case, we found a nice compromise. You know, we're gonna define upfront that asteroids are a certain size. We don't have to worry about differently sized asteroids and all the edge cases that entails. I think that's pretty good. We also noticed that like we have some repeating patterns with like updating object positions, rotating objects, things like that. So we could probably pull some of those patterns out into something a little bit more generic. And like maybe a little bit about you have to keep track of the difference between like relative positions and screen space positions and all those sorts of things when you're doing rendering and whatnot, and don't mix them up. So, I hope you enjoyed today's stream. I do these once a week. And around the same time, Tuesday evenings, 8:10 p.m. in the Eastern time zone. And yeah, if you want to follow me on the socials, you can find me on Mastodon. My instance is types.pl, and I'm Agent Ultra. It's me. Oh, it's there. I just can't remember how to type that in, but it's there. The code for this project that I'm about to push is on GitHub. github.com/agentultra/Asteroids. Of course, everything's going wrong for me today. There we go. Asteroids. So there's our asteroid rotation. We just did that. And we're looking good and pretty. So you can follow the project there, get the code if you like, mess around with it, whatever. And of course, do like Dundiff did and Polyvoid and follow here on Twitch to get updates. If you have notifications enabled and you want to know when I go online, sometimes I do surprise streams where I'm not on my usual schedule for funsies. And you'll get notified about those when I go online. Otherwise, if you're following on YouTube, you know what to do there as well. And that's that. We'll see you next week. May all your monads be free, and may your types always check. Take it easy.